Okay, these are the lesson 5 notes on density and thermal expansion. The first thing we're going to be talking about is density, but before we get to the notes, something that is in your homework that you may want to look at before you even start is this simulation. The link is in your homework, but what you have here is something you can play around with and get to know density a little bit better. Basically what we have here are different blocks in a water tub, and you're going to get to see how changing things affects how it floats. So right now I have a block that just barely wants to float, but we can change everything about it. If we go over here to my block, I can make it more massive. I can change the mass of that block. I just put it up to 10 kilograms. That is going to sink, definitely sink. But if I take the same block down to 1 kilogram, so now it only has 1/10 the mass it did a second ago, now it wants to float. Volume, on the other hand, is how much space it takes up, and increasing the volume is going to change the density as well. So we're going to come back and play with this in just a minute, but I thought I'd show you a bit of the toy that we have here. I'm going to be flipping between that toy and my notes as we go on here. Now, density is how tightly packed matter is inside of an object. Okay, so how tightly packed that matter is, if it's really tight or if it's really loose. A highly dense object is going to have very tightly packed matter. Here's what a high density object looks like. These particles are packed together really tightly, but as we get into less dense, you can see the particles are further and further apart. So high density is where they're really tight, but as we go down to low density, they're loosely packed together. You're going to want to pause this while I get this in your notes, but I'm going to go back to that little toy. Now, if we take things that have a high density, like aluminum, for example, here, there's a lot of matter packed in here. It's definitely going to sink. But if we take something with a low density, like styrofoam, that has a very low density, and it winds up floating. Okay, so the styrofoam, you should be able to tell, mostly air inside of there. It's very light. It doesn't want to sink. You can push it down, but it's going to pop right back up. But highly dense thing like a brick has a lot more matter. It's more dense, you could say. It's definitely going to sink. Moving on. Now, how we find density? There's a little math equation for us here. D equals m divided by v. And what this stands for is density equals mass divided by volume. So density, the thing we're looking for, you take your mass, you just divide the volume of that object. So for example, if I have an object that is 100 grams, I weigh it on a scale, it weighs 100 grams, and I know that it takes up 5 milliliters of space, or it has a volume of 5 milliliters, that object has a density of 20 grams per milliliter. Now, grams per milliliter, the grams goes there, and the milliliters comes here. Another example is going to be my metal example. So if I have a metal that weighs 20 kilograms, it's a sample with a volume with 2 liters, the math is the exact same. The density equals 20 kilograms divided by 2 liters. Now the answer, obviously, is 10, but the units are not going to be the same. The units for this example is going to be kilograms per liter. 10 kilograms for every liter. So that's our density. Now, how do you find out how much space something takes up? If I want to find the density of a rock, for example, you can't just measure it. We do something called displacement. Now, displacement is basically a way of determining the volume of an object using water. And it's used for irregular objects, like a rock, something you can't measure and just find out the volume of. So my first example here, we take a graduated cylinder, clearly 30 milliliters right there, and you drop your rock in. The rock pushes some of the water out of the way, forcing that water level up, and you can measure how high the water goes. In this case, now it is up to 40 milliliters. The question is, what's the volume of that rock? Well, the math is just simply 40 milliliters minus 30 equals 10. You should be able to kind of see that if you drop something in there and it goes up 10. In this case, it went up 10 milliliters. That our volume of our object is 10 milliliters. The next one, if before it is 19 and after it is 29, the volume of our object is also 10 milliliters. All right. The last example here has before being 64 and after being 68. So our little ring has a volume of 4 milliliters right here. So this is a way you can find the volume of objects that are irregularly shaped. If we take a quick look at our simulation, you'll see that this is doing the same thing for us. Notice over here, right now, there's 100 liters of volume being filled by this pool of water. So there's 100 liters of water in here. But if you drop the brick in, we just added 10 liters of volume to it. So as you play with this for the assignment, you can always notice over here, this number is always going to equal something going on elsewhere. Okay. The final part of the notes has to do with thermal expansion. Now, thermal expansion is a really important topic. We get back to it again and again in earth science. But thermal expansion is, as things heat up, their molecules start moving faster and faster. This makes them take up more space, so their density goes down. Okay, so let's take a look at a cool object. Those molecules are moving at a kind of a slow pace. However, if you heat them up, and by adding heat you're making the molecules move faster, what you end up with is the molecules moving faster and faster, but they're also taking up more space. So as you draw this, make sure you notice that these are closer together and not moving very quickly, but these have more space between them and therefore has a lower density.